Welcome to qnawire.
Okay, in this problem we have a voltaic cell that's going to be similar to a figure in your book 20.5. And it has an electrode half cell. One of the electrode half cells consists of a silver strip placed in a solution of silver nitrate. So we have one container with our silver strip electrode in there. Okay, so this is silver here. And it's in our solution of AgNO3. And then we have another container, other half solution here, which has a strip of metal in it, and the other metal is iron. So we have a strip of iron here, and it is in a solution of iron 2 chloride. So we're going to have our solutions connected by salt bridges here, and then our electrodes connected by some sort of wire. And the overall reaction for this system is that Fe solid plus 2 Ag plus, and that's aqueous, is going to yield Fe2 plus 2 Ag solids. So the first question is, what is being oxidized and what is being reduced? So what is being oxidized, our little mnemonic here is oil rig. Oxidation is losing electrons and reduction is gaining electrons. So the substance that is losing electrons is iron. It is going from 0 to +2 oxidation number. So it is losing electrons, therefore my iron metal is being oxidized. And then my silver ions are going from +1 to 0 oxidation number, so they are gaining electrons. So my silver ions that are part of the silver nitrate, they are being reduced. Part B asks, write the half reaction that occurs in the two half cells. So the half reaction with iron is we have iron metal, and it is becoming iron 2 plus ions, aqueous, plus the 2 electrons to balance that charge out. And that is my oxidation half reaction. And then my reduction half reaction, I have silver ions, they're aqueous, plus an electron to form silver metal, solid. So that is my reduction reaction, half reaction. Question C asks us which electrode is the anode and which electrode is the cathode. So the little rule here is vowel, vowel, consonant, consonant. So the anode is where oxidation occurs, and the cathode, consonant, consonant, let's try that again. And the cathode is where reduction occurs. So the anode is where my oxidation reaction is occurring. So that is where the iron half reaction is, where my iron metal is. And the cathode is where the reduction half reaction is occurring, and that is where my silver metal strip is and my silver ions that are being reduced. But in terms of the actual cathode, it's the silver solid silver strip that is acting as the cathode, and the solid iron strip here that's acting as the anode. Question D asks us, indicate the signs of the electrodes. And that's, so for electrodes, we have our iron, which is acting as our anode. And we have our silver, which is acting as our cathode. And because electrons always flow from the anode is going to be, and electrons are going to want to flow towards positive, right? So they're flowing from the anode to the cathode. electrons are negatively charged, so they're going to want to go towards the positive electrode. So by definition, the cathode is the positive electrode and the anode is the negative electrode. So they're flowing from the negative to the positive. At least they are in a spontaneous voltaic cell. Part E, do electrons flow from the silver electron to the iron electron or from the iron to the silver? So again, electrons are always going to flow. The way they're going to flow is they're going to flow from the anode, so from the oxidation, which is losing electrons, to the cathode, which is gaining the electrons. And since the anode is the iron, they are going to flow from the iron to the silver. And then finally, part F. Part F says, in which directions do the cations and anions migrate through the solution? All right, so that's talking about up here. So what's going to happen is at the cathode, start with what's happening at the cathode. So that would be on the left here. On the cathode, we have silver ions that are changing from silver ions into silver metal, right? So we are losing positive charge. So our positive ions, our cations, are going to flow from the, in our salt bridge, our positive, oops, not what I meant to say, our positive ions, our cations, are going to flow toward the cathode because we're going to need to make up for that positive charge. So they're going to flow within this, into the silver solution, the cathode. At the anode, let's look at what's happening. We have Fe changing into Fe2+. So we're actually getting a buildup of positive charge at the anode. Therefore, the negative ions, the anions in our salt bridge, are going to need to flow towards the anode in order to balance out that extra positive charge.